Hello everyone. So today we would like to look into data processing of post-university salaries. We will use Pandas. Pandas is panel data, allows you to process data. I'm not sure whether you have experience in using Excel, but you can think of Pandas as the coding version of Excel. It allows you to process data like series, which is a one-dimensional labeled array. You can think of it as a single column in a table. Data frame is a two-dimensional tabular data. You can think of it as columns and rows on Excel. So we will use Pandas to process and extract important information from the data. If you want to learn more about Pandas, you can come here. There are videos and interactive learning tools. If you're new to Python, feel free to go to more about Python and Pandas, and also there are links to previous workshops for you to build Python foundation. Okay, let's start. So today we will look into the analysis of post-university salaries of graduate by major. So college degrees are very expensive, and when you are deciding which major to go for, you may also look into how valuable it is in the job market. So today we will fetch data and check which degree have the highest starting salary in America, and which major have the lowest earnings after college, which degree have the highest earning potential, and what are the lowest risk college majors from an earnings standpoint. So there are three schools: business, STEM, and HAS. And we will learn how to explore the functions on Panda and how to clean, process, and sort and group data. This is Google Colab, so you can see there are text cells and code cells. Basically, we will use code cells to write and run our code. And when you see dot, it mostly indicates that I'm going to access the function in the library or the tool. When you see square bracket, it is used to extract columns or certain data. Go over these items and you will get ahead of it very quickly. Okay, so let's start. If you're new to Pandas, that's perfectly fine because this workshop is to build a foundation for Pandas. Okay, so the first thing we want to do is we want to import the Pandas library. So this is the syntax. We import Pandas. This is a library for data processing. As PD, it means that I import the library and I rename it to PD. So when I write code, I only need to put PD as the name of the library to make your code cleaner and shorter. And here I used the function called read CSV. It will read the CSV file you want to import and assign the Pandas instance to the variable called df. So let's see. I have put my data on this web page. So if you see this data right here, when you look into the raw data, you can see there are different majors and their starting salary, mid-career salary. So basically there's the salaries in different stages of their career. Okay, it looks a bit messy, so we need to use Pandas to organize this data. So this is the raw data, and we put it as the argument inside this parenthesis. It means that I'm going to read the data, and this is in CSV format, so I need to use the function read CSV. And this is the library Pandas. So the whole data frame is assigned to the variable df. So then we run the code. So how can I check what the data looks like? So we have a function called head. It will display the first few rows of the data. If I don't put any number, the default value is 5. But if I put a number in a parenthesis, it would just display that number of rows to you. So for example, if I put df, this is the variable that holds the whole data frame. And I use dot, access the function called head, and I run the code. You will see the first 5 rows of the data: undergraduate, major, starting medium salary, mid-career, medium salary. And if I change the number inside, I want to see 20 rows. Run the code again, you will see 20 rows. Okay, and also their group with schools. Nice. Okay, so the next thing we want to know is how many majors are there. Also equals how many rows does the data frame have. How many columns, what are the labels and the columns, and there are any missing values. So we need to check the shape of the data, and then we need to clean the data. There's a very interesting attribute of this class called shape. So when I say dot shape, it's not a function, it's just an attribute. When I say dot shape, it will display the number of rows and the number of columns. So here there are 51 rows and 6 columns. And now we want to clean the data. A function in Pandas, it's called isNot. It will track whether there is any missing value in your table. And if you find anything, you can use tell. Suppose the missing value is in the last row, you can use tell to display the last few rows of data. And if you put dot drop not, it will drop all the missing value in the data frame. Suppose the 50th row, there's a missing value. If you put drop not, it would delete the whole row. For example, when I run the code isNot, it will show you if there isn't missing value, it will return false. But if there is any missing value, it will return true. So apparently, in the row 50, there are 5 missing values in total. Let's see what is the. Okay, so because it's just a row for the user to understand what the source of data is. So basically, it shouldn't be a part of the data. We shouldn't include this in the data processing. So we will need to drop the whole row. If I say drop not and in place, it means that I will drop the row and assign the whole data frame back to the variable df. If I don't put in place true, it will create another data frame with this row deleted, but df still holds the original data frame that the 50th rows remains. So here I need to put df drop not. Now the 50th row is gone. We can display the last few rows again. Okay, now the last row was gone. Okay, great. Now we want to know the college major with the highest starting salary. That's the most exciting thing. Want to know if you choose this major, you will become a billionaire, millionaire, you will become really rich. Okay, that's what we want to know. We want to know which major to choose. So as I've mentioned in the first play, if we use square bracket, it allows you to access or extract column. And if you extract the column name is starting median salary. If you use the function called max, it will display the greatest number in this column. So if I say I want to know what is the greatest number in the column starting median salary. Okay. If I say df starting median salary, it will extract the whole column as a series, a single column. And then I use the function called max. It will display the greatest number in this column. So apparently it's 74,000. But the thing is that I want to know what major it is. So I can scroll down and use ID max to locate the index of the row. Once we get the location, we can put the location to 43. So this is basically an attribute with a list of values. So if I say log square bracket 43, it will extract these columns value. So undergraduate major, these columns value which is located at 43. I can also write it just with the bracket 43, then it will give you the value at 43. So let's try it out. Okay, so here, if I put max, it just gives you the greatest number, but if I put IDX max, it will give you the exact position of this number. It's called 43. So I need to put 43 to here, location, and it will extract the value at 43. So in undergraduate major column, physician assistant, the starting median salary is the greatest among all the other majors. And I can also write 43. They are the same. What if I say I don't want to extract only this column. I want to extract the whole row at 43. Then I can do df.log 43. It will extract every value in the 43rd row. Okay, so undergraduate major is physician assistant. Starting minimum salary is the highest, 74,000. Mid-career, medium salary, mid-career, 10th percentile salary, and mid-career, 19th percentile salary. So for 10th percentile salary is the lowest in their income pyramid, and 19th percentile salary is the highest, like at the tip of the pyramid. Okay, so I want you to see this challenge. What college major with highest mid-career salary? Sometimes it doesn't really matter how much you earn in the first place when you enter the workforce. It's all about career progression and development. Probably some people prioritize mid-career salary. So we'll look into the highest mid-career salary and how much do graduate with that major earn. And also want to look into the lowest starting salary and how much do graduate earn after university, and also lowest mid-career salary and how much they earn. So you can spend time trying to figure out by yourself. We'll get back here in 10 minutes. Okay, I think you can pause the video and wait for and work on it. Give you a 10-minute counter. We're going to start anyway. Okay, so this is the answer. It's exactly the same. The only thing that I need to do is to change the first place we put starting medium salary. So here I just need to put mid-career medium salary. Okay, so this is undergraduate major, and this is mid-career medium salary. Here, what I do is I'm going to extract the max, the position of the row with the highest, the greatest number. So I'm going to find out the greatest number in the column mid-career medium salary. And this is the major, undergraduate major. So I can put something like this and this. Okay, so it means that once I get the ID, okay, if I execute this code, you will get the ID, the position for the greatest number in mid-career medium salary. And that number, if I put it here, if this result is the number, then I put DF undergraduate major. Inside the bracket should be the number. So here it's more like a short, cleaner code to directly extract the undergraduate major with the highest mid-career medium salary. And here is for you to extract the highest medium salary. So let's see how it works. For example, if I say I want to print DF undergraduate major, okay, and in this column I need to identify the position, the number, so that I can extract the highest number of in the column mid-career medium salary. So this line of code can be decomposed into printf mid-career medium salary, and here if I put ID max, okay, and let me comment out this code. Of course, it will give you the number 8. So number 8 means that the position, location of the greatest number in this column is 8, at a position 8, index 8. If this line of code returns 8, why don't I just put the whole line of code here? Because this is the place I'm going to put the number, the location where there is the greatest, highest mid-career medium salary. So I just put it here. And this line of code is this one. I put 2 different lines of code and combine them into a single line of code. If I execute the code, okay, I think I have a typo. If I execute the code, you will see chemical engineering. So for mid-career medium salary, the highest is in chemical engineering. So let's visualize this. Okay, chemical engineering has the highest mid-career medium salary. Spanish has the lowest starting medium salary, and education has the lowest mid-career medium salary. Oops, I am in education. Okay, scary. Okay, so try to play around and get yourself familiar with this function. Okay, now I'm going to move on to another function called lowest risk majors. So what is lowest risk major? Lowest risk major means that we're going to subtract the mid-career 90th percentile salary, those who earn a lot at the tip of the pyramid, and tries to find out the gap between the tip of the pyramid and the bottom of the pyramid, those who earn not that much at the bottom of the pyramid. If there's a huge gap, it means that it is very risky, because if you choose that major, you may end up being at the bottom of the pyramid. And if there's no gap, it means that it is not really risky, because if you choose that major, you are assured that you will earn pretty much the same comparison with all the other people in the same industry. So if I choose, the thing is that, if I see someone studying finance and earn a lot of money, but if this is very risky, if the gap in the pyramid, the gap is huge, it means that you may end up being at the bottom. So it's not that, there are people in this industry, they earn a lot. You also have to look into the income pyramid in the industry. Okay, the best case scenario is that they earn a lot and the income gap is not that huge, or income gap is not significant. It means that if you choose that major, if you are in the industry, you are sure that you will earn a lot. Okay, so what we're going to do is use the column mid-career 90th percentile salary minus DF mid-career 10th percentile salary. It means that we're going to use one column minus another column. So it will return another column with the difference. Okay, I will demonstrate it later, or you can use the function subtract. And then we're going to insert the difference as a single column to the original data frame. So we call it spread, how huge the gap between two columns are. Okay, so this is the coding area. If we use DF mid-career 90th percentile salary minus mid-career 10th percentile salary, it will return a series, a column with difference. So this is I think the first major, not sure what the first major is, but this is the difference between these two columns. Okay. And here I assign this column to a new variable called spread column and insert spread column to the original data frame, and I put it in the second place. So if I execute it and view the data frame again, you can see there's a new column called spread, and this number came from the difference between this and this. Those who earn a lot and those who earn not that much in the same industry, or who all graduated from accounting. Okay, so why do we need information? As I've mentioned in the first place, we want to know what major is high risk or low risk. Sometimes we say high risk, high potential, low risk, low potential, but some it will guarantee that you're going to have the basic proper income. Okay, so we're going to use another function called sort values to look into different majors and see which one has the highest potential, or put it this way, is the most risky one. Okay, so low risk one, it means that the gap is small. We're going to use sort values, so data frame dot sort values, and by which column do you want to sort the value? So I want to sort the value by the column spread. So spread, and here I want to display undergraduate major column and spread column, and give me the first 5 rows of data. This is what we'll do. So let's execute the code. Low risk, and this is extraction. So if you put square bracket, you can extract a single column. But if in the square bracket you put a list, okay, a list with different columns name, it means that you can extract multiple columns and display them. So if I run the code, you can see there's a column undergraduate major, this is spread. And because I sort them already, is in ascending order from lowest to the greatest. So the least risky, or we can also say the major that doesn't bring you high potential, is nursing. Means that for those who graduate from the major, they earn pretty much the same in the income pyramid. And you can see the top 5 are all about healthcare, or medicine related, or this is healthcare, nutrition, physician assistant, only Spanish. Okay, so the only exception. Now we want to use sort value to find the degrees with the highest potential, means there is a huge gap the spread is high. So it's also for you to play around. You can pause the video for 10 minutes and try to do it by yourself. Okay, 10 minutes just passed. Okay, let me show you a code. Okay, so it's the same. We just need to change ascending to false. So it will display the data from the greatest to the smallest. And the same, I want to display 2 columns. Okay, oh, great. So the majors with the highest potential is economics and finance. It kind of makes sense. For those who major in finance or economics, if they do investment or if they just go to bank, their earning may be quite different and there may be a huge gap. So you can be a hedge fund expert on a lot of money. You can be just a data governance specialist in a bank. They all belong to the same industry, but different functions or different roles. Their income are quite different. Okay, math, marketing, philosophy. Okay, philosophy, very interesting. Maybe you become a popular philosopher and you own a lot, or you publish your own books, or maybe they do something else. Okay, nice, very interesting result. Next, so for the previous sessions, we'll only look into majors, but what about school, like human and art, business, and STEM? There's a function in Pandas which allows you to combine, where it allows you to compile the unique values in the column and categorize them and bring them all together, analyze the data. For example, if we check the original data frame, there are groups. Okay, you can also call this schools. Different majors belong to the same schools. Right? There are different majors, and some of them belong to business, some of them belong to STEM, some of them belong to HAS. What if I want to know, okay, in this table, how many undergraduate majors belong to business, how many undergraduate majors belong to STEM or HAS? Correct me if I pronounce it wrong, it's HAS. Okay, so we need to use group by. So we can group by the column group, and we can calculate how many times this school appears. This number will indicate how many majors belong to a certain school. And also we can summarize or take the average of the mid-career median salary for each school and see which schools tends to have the highest starting median salary. Okay, so let's do it. Goodbye. So here I use the function goodbye, and the parenthesis I put the column, the name of the column I want to group by, and here I put count. It will count how many times this group appears in the table. It also indicates how many majors belong to this group. So if I press the button, it will just show you for business school there are 12 entries. It means that for each column there are 12 entries. So the business school appears 12 times. It also means that there are 12 majors belonging to business school, and there are 22 majors belonging to HAS, 16 majors belong to STEM. Okay, so we can also check mean. Means that I want to take the average of the starting median salary or other numbers and see which school has the highest average income. So if I say mean, you can see for the spread, HAS has the smallest spread, and for starting median salary, STEM is leading, with HAS lagging behind. It's a huge gap. Okay, don't change your mind if you have decided to study HAS. You have great potential. And you can see mid-career and item salary. For those who earn a lot of money, there's a huge gap between different schools. It's a pity that Haas always is the last. Okay, so this is for you to change the format from multiple decimal point to a single decimal point. So you can also get it in the document. It's not something you should memorize, but it makes your data looks prettier. Nice. Okay, the last thing we want to do is to visualize the data. So if I use Matplotlib library, I can visualize the data like this. You can always fine-tune it, and maybe you just need to visualize some of them. But just to give you a picture of, okay, for 90th percentile column, and so many different majors, who is, okay, so it should be economics. Yeah, that's what we just saw. Economics has the highest 90th percentile salary. It means that those people who graduate from the major, they're going to earn a lot of money. And even those people in the same industry, there's a huge gap between their income. Okay, so you can change these into other columns. For example, starting median salary. If I put starting median, it will visualize starting median salary. Okay, this is starting median salary. Okay, I should change the title, but in any case, fit. Okay, let's see which major has the highest starting median salary. I think we just stick into it, and it should be physician assistant. Yeah, physician assistant. Okay, so you can change the code and play around. Okay, so that's it for today's workshop. It's just to give you a picture of how you can use Pandas to process and transform the data and extract the data to gain some insight. And that's it. I hope you enjoyed the workshop, and don't forget to go through other resources to get yourself more familiar with the functions in Pandas. I will see you then. Have a good one.